Welcome back, student, to design and analysis of algorithm subject. Today we are going to see about the heap sort. Before going to that, we will see what we have done in the previous lecture. In the previous lecture, we saw the disjoint set operation and we saw how to represent the sets, and we saw the union operation and find operation. This thing we have discussed in the previous lecture. You can go and watch the video if you did not watch the video. And today's lecture we are going to see the elementary data structure. What are the data structure? Already you have completed the subject data structure in second year. So just what is the use of that data structure in design and analysis of algorithm? We'll see that, and we'll see the heap and heap sort. Okay. First one is elementary data structures. Elementary data structure. Why are we studying data structure, and why you studied data structure? Data structure is very important topic to understand the design and analysis of algorithm. For this data structure is very important for this subject because we are going to work on the data structures, that is elementary data structures. Whatever the data you are storing, where it is storing and how it is storing, that's matter. Okay, so that is data structure we are going to use, and we will see the elementary data structure. First one is a array. Okay, this one, first one is array. An array will represent as like this. An array start with 0 and end with n minus 1. Already you have studied the array in C programming, C++ and data structure. Okay, so I am not going to go in deep about the array. Just I will going to show you the elementary data structures are this: array, list, stack, queue and tree. So array will represent as like this. The next one is list, and the list is represent as like this. It is maybe in a vertical or horizontal, but that should be connected like this, list one by one. Okay, this is represent the list. Third one is stack. What is stack? Stack is some bucket is having some of the data, and whatever the things you are storing here, that will be stored here, and in the form of LIFO. What the thing it will follow? Stack will follow the LIFO, 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 last in first out. So whatever the thing we are going to inside in the last, that you are going to be remove first. Okay, in the stack, whatever the thing you are going to be stored in a stack, the last element will take out. Means when you are inserting the element in the stack, that we call push. Okay, PUSH. And when we are removing or when we are taking from the stack, that is we used to say pop. Okay, push and pop. Next one is queue. Queue is follow the it's follow the FIFO, first in, first out. First in, first out means who is going to enter into the line, the first person will come out from that line. Okay, so this is also one type of data structure. And the last one is tree. Last one is tree. In the form of tree, you can see how the data structure is there. So these five are very important. Elementary data structure: arrays, list, stacks, queues, and trees. These all the things are there. um, this is very important. Okay, if you know all those things, means already it is completed in the second year data structure subject, so that will be easy for you to understand the design and analysis of algorithm. In some languages these are basic data type, in other they need to be implemented. These are some places it is basic data type, and some places we need to implement. Okay, what is heap? So before going to the heap, to explore the implementation, testing, and performance of heap sort algorithm. Okay, so a heap is a data structure. What is heap? As I told you, the data structure here, array, list, stack, queue, tree. Then there heap is also one type of data structure that stores a collection of objects with keys and has the following properties: complete, binary tree, heap, order. Okay, what is heap? Heap is a data structure that store a collection of object and has the following properties. Okay, complete, binary tree, heap, order. It is implemented as an array where each node in the tree corresponding to an element of the array. Okay, so this is a heap. So what is a heap? The binary heap data structure is an array that can be viewed as a complete binary tree. When it is a complete binary tree, each node of the binary tree corresponds to an element of the array. The array is completely filled and all level except possibly lowest. So here this is a array 19, 12, 16, 1, 4, 7. So here you can take 19, 12, 16, 1, 4, 7. You can make a tree, simple tree. We have not done anything. Whatever the number is getting first, we are writing that. That's it. Heap. So the root of the tree, a of I, a of 1. Okay, as you know, in the graph the first one is a root node. Okay, the first one is a root node, this one is a root. First one is a root node and the rest of the nodes are called leaf node. Okay, so the root node of the tree A1 is a given index I of a node that indicates of its parent. Leaf, left child and right child can be computed. So parent I, parent root node is also known as parent. Parent node, parent is I, return floor I by 2, and we are dividing in the 2. Left I, return 2I. Okay, left side is a 2I and right I is return 2I plus 1. So this is a heap. So this is a simple algorithm for the heap. Give an index I. When you see the example, then you will easily understand. Heap order property. For every node v other than the root, the key stored in v is greater or equal, smaller or equal for the max heap than the key stored in the parent of v. In the case of maximum value is stored in the root. So in the heap we are going to see the two things, min heap and max heap, means minimum heap and maximum heap. Okay, so that we are going to see which one should be in ascending order and which one should be in the descending order. So the definition of this is max heap is store data in ascending order. Okay, remember this. Store data in ascending order has property of a of parent I, whatever the parent I, the root node, that should be greater than or equal to a of I, whatever the value we are going to give, that should be equal or greater than. Min heap store data in descending order and has property of whatever the parent node we have, that should be less than or equal to a of I. Okay, remember this. I will show you the tree of max heap and min heap. So what is the max heap? Max heap data is in ascending order and min heap is stored in descending order. Okay, so max heap, in the max heap what we have telling, the greater this one should be greater than or equal to a of I, should be greater than a of I. So this is 19, the maximum value is here 19, 12, 16, 1, 4, 7. Next, here min heap is opposite to max heap, as whatever the descending order, it follow the descending order. 1, 4, 16, 7, 12, 19. Okay, so this is whatever the procedure you are going to take, but the root node should be less than. Okay, root node should be less than or equal to a of I. A of I is nothing but at the left and right child. Okay, how will you insert in the heap sort? If I want to add the new element to the next available position at the lowest level, so how can we add? Like here it is empty place and I want to add here some data. I want to add some data here. So how to add? Okay, general, in the max heap the general strategy is going up. This percolate is nothing but like going up or bubble up. If the parent of the element is smaller than the element, then interchange the parent and parent and child. Okay, you need to swap the data. If the above element is smaller than the child node, then we need to change. In the mean, if opposite, if the parent of the element is larger than element, then interchange the parent. Okay, I will show you the example here. Example, this is my the tree 19, 12, 16, 1, 4, 7. Okay, and I am adding the new insert 17. I am adding 17. So what we are doing here, now we are doing here, what is this? It is a min heap or max heap. Remember, every time whenever we are getting the highest value at the top, that is a max heap. Okay, whenever we are getting in the minimum element on the top, that is minimum heap. So we are performing the maximum heap. Okay, so in the maximum heap, our root node should be high. Okay, so here 19 and 12 in 16. Yes, 19 is the highest. 12 1 4. Yes, 12 is greater than 1 and 4. Good. Now here, after inserting the 17, now check 16 is greater than 7, but 16 is not greater than with 7. So whenever we will get like this situation, okay, this situation, at that time you must swap, you must swap the data 1912, and this is swap and percolate up to maintain the heap property. To maintain the heap of property, we need to move up to maintain the heap property. Did you understand this? This is, we perform the operation for the max heap. Okay, so this is a thing. We added the new element. If the new element is greater than the root node of the given tree, from the root node, if it is more greater than, then we need to swap it. Okay, how will you delete? Delete max and delete min. Copy the last number to the root. Overwrite the maximum element stored there. Restore the max heap property by percolate down. When you were inserting the element, that at the time we were doing the up, when we are deleting, when that time we are doing down. Okay, copy the last number to the root, overwrite the minimum element stored there, restore the min heap property by percolate down, going down. Okay, now we will see the heap sort. Okay, till now we saw the about the heap, what is heap and how to insert the data in the heap, and the heap properties should be managed, and how to delete and all the things. Next is heap sort, a sorting algorithm that works by first organizing the data to be stored into a specific type of binary tree called a heap. Okay, a sorting algorithm that work by first organizing the data to be sorted into a special type of binary tree called a heap. So whenever we are performing the heap, at that time our data should be in sorted. Procedure on heap: first one is a heapify, second one is build heap, and after that we need to sort. Three steps are there. Procedure: heapify, there is one algorithm. Build heap, with the help of algorithm we will find the heap, and we need to write the algorithm for the sort also. Okay, we'll see one by one. Heapify, pick the large child key and compare it to the parent key. If parent key is larger than heapify, then quits. Otherwise, it swap the parent key with the largest key, child key, so that the parent is now become larger than its child. Okay, the same thing, we need to swap the things here. So in the heapify a comma I, heapify a comma I, and capital I is left of I and R is right of I. If I less than or equal to heap of A and A of capital I is greater than A of small I, what we are doing here, we are checking the condition. If this condition is satisfied, if this condition is satisfied, then larger is I, capital I, else largest is small I. Clear? If A of capital I is greater than A of I, then only it will be larger. Otherwise, the previous A of I only is a larger. Next, if R less than or equal to heap size of A and A of R greater than A larger, okay, whatever the value we are going to get here, okay, that we are taking here. We are not taking A of I capital I or A of small I, we are taking here A of larger. So whatever the stored is, whatever the value is storing here, that is we are taking here. Then larger is R, right side. And if larger is not equal to I, means if it is not equal to I, then swap A of I to A of larger. We need to swap. Heapify A comma larger. Okay, previously what is A comma I, then at the last, if the I value is not larger, so we need to make a swap and we need to change to heapify A larger. So this is a algorithm how to pick the largest child key and compare it to the parent key. Okay, how to pick it, the largest child key, and compare it to the parent key. Clear? So this is the algorithm. When we will see the example, then you will understand. We can use the procedure heapify in a bottom-up fashion from down to up to convert an array A of 1 to n into a heap. Since the element in the sub array A of n by 2 plus 1 so on to n are all leaves, the procedure build heap goes through the remaining node of the tree and runs heapify on each one. This heapify, okay, run on each one. The bottom-up order of processing node guarantee that the subtree rooted at children and heap before heapify is run at their parent. Okay, so we need to build heap now. Okay, as I told you, heapify is finished. Now we are building the heap. Heap size of A is length of A, that should be there, for I is equals to modulus of length of A by 2 to heapify A comma I. When this is there, this function will call this block of code. Whenever we call this function, it will execute this algorithm. Okay, heapify size is equals to length of AI, for I is modulus length of A by 2. Okay, This is build heap. Heap sort algorithm. In the heap sort algorithm, sorry, yes, the heap sort algorithm start by the using procedure build heap to build a heap on an input array a of 1 so on to n. Since the maximum element of the array is stored at the root, it can be put into its correct final position by exchanging it with a of n, the last element in a. If we now discard node n from the heap, then the remaining element can be made into heap. Not that the new element at the root may violate the heap property. All that I needed to restore the heap properties. Okay, we need to insert the element, delete the element and all the things, but whenever we are building the heap, we need to consider, we need to check the heap properties. That should not be violate any rules of heap property. Heap sort of a, build a, for I is equals to length of a, do swap. When a length a is I, do swap a of 1 is a of I. If both are equal, then heap size of a is heap size a minus 1. Heapify a comma 1, the same heapify algorithm is calling here. So if you have some difficulty to understand these algorithms, no problem. When we see the example, then you will easily understand the concept. So here convert the following array to a heap. Okay, to a heap. So the picture is array as a complete binary tree, like it is C 16 4 7 1 12 19. We cannot say this is a heap and we cannot say this is max heap or min heap, because here 19 is the highest and lowest is a 1. These both are not in the root, so this is called a complete binary tree, but we cannot say this is a heap. So how will you convert this? First, 16 4 7 1 12 19, this is a data what we have. Okay, so now in the first step we need to go with the maximum heap. So if the leaf node is a maximum and the root node is minimum, so we need to swap here. So we swapped here, 7 is here and 19 is here. So we did the interchange between 7 and 19. Why we did? Because leaf node should not be greater than of the root node. Okay, 19 is greater than 7, so 7 is a root node of the 19 and 19 is a child node of the 7 root node. So we swap the first step, and the next one is after this 12 and 4. Here also 12 is greater than 4, so we are swapping here. Next, here at the last what we got, 12 1 4. Yes, 12 is greater than 1 4. Very good. 19 is greater than 7. Now the next step is 16 is greater than 12. Yes, true. 16 is greater than 19. No, false. When it is false, this is a greater than the child node that should be replaced with the root node. So 19 12 16 1 4 7. So once it reaches the root node, that means it is a largest element in the given array. Okay, heap sort. Heap sort algorithm consists of two phases. Build a heap from an arbitrary array. Use the heap to store the data, to store the elements in the descending order. Use a heap, min heap, to store the element in the increasing order. Use the maximum heap. Okay, fine. So whatever the heap do you want to use, you can use min heap or max heap. So here example of heap sort. Okay, example of heap sort. Now we are performing the sort on this given operation. Clear? So this is not in a sorted order. So here the sorted given data is 19, 12, 16, 1, 4, 7. So this is not in the sorted order. So what we are taking, first the root node we need to take out because that is a biggest one, and move the last element to the root. Okay, send the last element to the root and sorted. The 19 is a sorted because this is a largest element in the given array. So here in the second one, after sending this 7 to root node, here 7 is a root node now. Then after 7 we need to check with the help of Heapify algorithm. We need to swap the data. If the child node is greater than root node, then we need to swap the data. So 16 is going up and 77 is going down. Next step, 16 is went to up root node and 7 is a child. Now 7, 12, 1, 4. So now the root node is a highest element in the given array here in this. So we have to take out this out. 16 is out and give here in a sorted. Okay, and which one is a minimum? The low level last element of the root should be sent to the root. Okay, 4, both are in the same level, but after getting the left node we will get the right node. The right node when we have, then this is a last node. So how it will be displayed? 4, 12, 7, 1. So in this 4 is lesser than 12, so the child node should not be greater than root node. So what we need to do now here, we need to replace, means interchange. We need to do the swap. When we do the swap, what will be the value? 12, 4, 7, 1. So what is the 12 now? 12 is the largest element in the given array. So we need to take out 12 from this graph. Okay, when we take out, and that we will send to the sorted list, and the last element of a tree should move to the root node. So what is the next? 1, 4, 7. So here also the same thing. What is the thing here? 7 is a greater than 1. So we need to swap this. When we swap, 7 will be at the top, and 4 and 1. Okay, so here the 7 is we need to take out, because this is the largest element in the given array. This 741, which one is the largest? Is 7. We need to take out the 7 and move the last element at the top. So 1 is sending to the root node. So what is the answer? 1 and 4. So when we apply the heapify algorithm, so we need to swap, because 4 is greater than 1 and 1 is smaller than 4. So root node should be greater than child node. So here it is not, it is violating the heap properties. So it's changed to 4, and the 4 is take out and sent to the sorted list. Okay, move element sent to the root node. Only one node is there, then we need to take out 1 also from the root node. Then we will get the sorted order 1 4 7 12 16 and 19. Okay, so we got in increasing order 1 4 7 12 16 19. So we got the answer in increasing order. So as we discussed here, to sort the element in the increasing order, use the maximum heap. We use the maximum heap and we got the increasing order. Okay, our sorted is 1 4 7 12 16 19. Clear? I hope you understand this. Okay, and we'll see what is a time complexity, time analysis. Build heap algorithm will run in order of n time. Okay, order of n time. Whenever we have a n value, at many time it will run. There are n-1 classes to heapify. Each call required order of log n time. Heap sort program combine build heap program and heapify. Therefore, it has the running time of order of n log n time. So the total time complexity for this is order of n log n. So what is the time complexity of the heap sort? Is total heap sort complexity is order of n log n. Next, what are the possible application? When we want to know the tasks that carry the highest priority given a large number of things to do, at the time we will use this. Interval scheduling, when we have a list of certain tasks with start and finish time and we want to do as many tasks as possible. Sorting, a list of elements that needed an efficient sorting algorithm. So these are the some of the possible applications. So what is the conclusion? The primary advantage of heap sort is it efficiency. The execution time efficiency of heap sort is order of n log n. The memory efficiency of the heap sort, unlikely the order other n log n sorted, is constant, order of 1, because the heap sort algorithm is not recursive. What is heap sort? Is not a recursive. The heap sort algorithm has two major steps. The first major step involves transferring the complete tree into a heap. The second major step is to perform the actual sort by extracting the large element from the root and transferring the remaining tree into a heap. Okay, so this is a thing what we have done today. Okay, and uh, so these are the things, and we'll see what we have done in the today's lecture. We'll see the summary what we have done in today's lecture. We saw the elementary data structures. What are the elementary data structures? Like array, list, stack, queue, tree. Okay, and heap sort is also one type of data structure. And we saw the heap, what is heap, and then we saw the heap sort, how to do the sort of the given tree or given array. Okay, so these are the thing we have done in today's lecture. Thank you. If you have any doubt, any problem, any related issue related to the voice or video or subject, you can message me. I can improve that if it is any issue. Thank you very much. We'll see you in the next class.